introduction for Rook, I feel bad. I should be introducing Jeff McJunkin as well, but Derek is relatively new, like in my universe. I think it was probably about a year ago or 2 years ago. I mean, there's been SANS conferences, right? But as far as teaching, maybe 2 years ago, you kind of entered that process.
Yeah, and, 2.5-ish.
Something like that, yeah. And I got a chance to co-teach with him in SANS Hackfest in DC. And I got to be honest, like within the first 10 minutes of him teaching, I'm like, I'm unnecessary in this entire equation. And he was actually a big reason why I stepped away from SANS 504. I know that sounds ominous,
but that on me.
Yeah. So stepping away from SANS 504, one of the big things that I really wanted to have was an incredibly strong person to hand the class to, and we got that in Josh. Josh has done a rocking job. And then I wanted to have a large number of instructors that I knew could just kick ass. And I think Rook was the tipping point. Like once I saw Rook and we have Mick Douglas and a whole bunch of other people, it was like, yeah, this class is going to be fine. And that was a great opportunity for me to step back. And as far as stepping back, I'm going to step back now and let him talk about web hacking beyond simple alerts.
John, thank you so much. I'm unworthy of that introduction. I really do appreciate it. So welcome, everybody. I am glad that you could join me virtually. I'm a little bummed that you're not here physically with me, as I am in San Diego, but you can't see outside. It's actually raining, and it's going to be raining pretty much all weekend, so you're not really missing out on the great San Diego weather. But welcome to my talk, Web Hacking Beyond Basic Alerts. And this talk is a few different things for me. It's a introduction to something I'm very passionate about, which is breaking into websites and compromising the perimeter of enterprise networks and computer networks through a website. But it's also a chance for me to help explain some of the nuances of web attacks. I do a lot of interviewing. I run a team, and part of my interview process is some questions, and I see a lot of repeated mistakes, misunderstandings of how websites work. Okay, so as part of this, I've tweeted a couple times that this is going to be a very hands-on, very demo-driven presentation. I do have slides to help introduce some things, but it's also going to be very demo-driven. So we have our first demo already right off the title slide. So let's jump right into that. My totally not Tor password into Cali. And the web application that I'm going to be using today for my demonstration is Rook Aviary Services. It's something that I originally wrote to help with SANS 504 to kind of upgrade the web lab a little bit, but it's evolving into something much bigger than that. So it's a vulnerable by design web application. It is very small. It's very simple. There's not a lot of really complex challenges to it yet. I'm building some in, but it's more illustrative, right? It's to illustrate problems and to illustrate vulnerable code, as well as taking advantage of that vulnerable code. And so this talk is going to be pretty illustrative rather than like super realistic, bypassing a lot of filters and whatnot. But we can't go beyond XSS found until we start with XSS found. So I want to do a quick demonstration of a JavaScript alert, just to kind of show like where we're starting from, right? And this is a very basic cross-site scripting that you might find in like a bug bounty or something. And it's just, we find something that if we, actually let me show you what it looks like before we take an exploit. If we want to search for cats, right? And we run the search and it's like no results for cats. We're seeing that our input is being reflected back to us. And so if we see that, we might be able to reflect code back to us. And we'll explain why this works in just a second. But if we put in a little bit of JavaScript, and all this does is say, hey, we've got some JavaScript here, it's coming. And then we put a little bit of JavaScript, and it's just, I want to pop an alert box that says XSS found. And then we're going to close out our script tag. When we submit that, it gets reflected back to us, and we get this pop-up box. So this JavaScript runs, all right? And when we click OK, we can look at the source here. And if we scroll down, we actually see, let's see if I can blow this up a bit. When we blow this up here, we actually see that our content is being reflected back to us. But since browsers run JavaScript, it's actually going to run this code that we created, that we put into it. So this is a content injection vulnerability, and cross-site scripting is an injection vulnerability, and it's running our code. So that's XSS found, right? So now that we kind of have an idea of how that works and what's going on there, we can now move beyond that. So let's go ahead and move beyond that. So let's talk about why. Why this talk? Well, the big thing is that the web is the perimeter. All right. When you have a big organization or even a small organization, a lot of times companies obey this kind of eggshell model of security, which is they have a really hard, crunchy exterior, but the inside is really soft and gooey. And while a lot of their critical assets are inside of the firewall, web applications by design, because they're public information distribution engines, they have to be outside. And then on top of that, a lot of modern web applications are dynamically generated, right? They're data driven. And so they're often connected to databases. Now, you don't want a database just hanging out in the wind, right? You don't want it out in the public. So the database is usually inside, like behind the firewall, and they have to poke holes to allow that public web server to connect into that database. And even if it's not it gives us a foothold into their IP space. So some of the things I've seen actually is maybe I don't get to jump directly from a web server directly into their internal network, but they'll have some sort of, explicit allow or lockdown cloud environments that only allow connections from their IP space. And I have seen companies include their DMZ, where their web servers are, in that allow list. And so you can jump from their public DMZ web servers into their super lockdown cloud environment. So the web's the perimeter, and also web is ubiquitous, right? So web servers are everywhere. Content is being served by web servers or web-like servers all over the place. And even a lot of mobile applications are really just reskinned websites. They're like web applications that are being served from within like a wrapper app. And so if you get really good at breaking web applications, if you understand how web applications work, you're not instantly ready for mobile pen testing, but it's a good jumping off point. Okay, so let's talk about the mistakes that I see a lot. This is pretty straightforward. A lot of people know that there's like server-side code and client-side code and a little bit about the differences between them, but I want to cover it real quick before we jump into more of the nuances. So on the server-side technologies that happen is you've got the web applications like the Apache or the web servers, So like Apache or Nginx, Flask has like a dev web server included with it. PHP has a dev web server included with it. But that's where the server itself lives. We've got the server-side code, right? So PHP, Python. It hurts me to say this, but JavaScript can be ran on the server. A little weird, but we've got server-side code, and then also along with the server area, we tend to think of like databases are also like server-side. We'll get into that in a minute. Additionally, we've got client-side, right? And that's where the browser is rendering like JavaScript and HTML and CSS and things like that. So it's only rendering the client-side code. And this is going to be important as we go further down the road, but web browsers run HTML, JavaScript, CSS, some other stuff sometimes, but mostly those. And then the servers are running the PHP and the Python and the Ruby and the Go and the Java, et cetera, et cetera, et cetera. So also, none of these charts are supposed to be exhaustive, right? So if your favorite web framework doesn't show up on one of these charts, I'm sorry. I could do an entire talk just on web frameworks. But here's some nuance, right? Here's the more nuance, right? So really the server side is much deeper than this, right? So on the server side, we've really got a couple different layers that are going on. First of all, as I said, there's like the Apache server or the Nginx server, as well as the PHP or the Python code. And we kind of split those up into two different sections as well. What happens is the server itself, whatever is acting as the server that's actually binding to 80 or 443, receives the request and does some processing on it. It decodes the URL encoding, so that %20, %3D kind of stuff. It decodes that. It parses out the incoming path and the variables. So it actually does that first. So it parses out the path and then parses out decodes the URL encoding. It decodes the request based on what the application type is, things like that. And the exploits available at this layer is really just against the server code itself. So malformed request attacks, request smuggling happens here, denial of service, BOFs against the server, et cetera, et cetera, et cetera. Below that, and this is still server side, below that is the business logic, okay? And the business logic is where the path gets routed down to the code that's executing, and the actual server-side code runs, right? So this is the Go, Java, Python, Ruby, PHP, etc. It parses the data that's coming in from the request, and then it formulates its response. I don't want to say compiles because it's not compiling code, but it compiles all of the data that it needs to send to the browser, puts it into languages that the browser can understand, so HTML, JavaScript, CSS, etc., and then sends it back down the pipe. This is where a lot of the server-side exploits come from, right? So exploits, we got injection attacks, include attacks, uploads, either arbitrary uploads or upload bypassing, server-side request forgery, et cetera, et cetera, et cetera, et cetera. Once that browser-readable code comes down the pipeline, the browser receives it, processes all the client-side languages, JavaScript, CSS, etc., and it presents the information to the user. It's often inside a sandbox, okay? So, in fact, Pwn2Own and various other Pwn competitions happen and offer hundreds of thousands or millions of dollars to escape the sandbox in browsers. And so I sometimes see in interviews where people try and do like code execution with JavaScript, and if that's on the browser side, it's not going to do what you think it's going to do unless you're a really, really, really good hacker. But browser exploits, which are pretty rare, cross-site scripting and social engineering, a lot of time those are combined. Those are the types of attacks that you're seeing at the browser level. I promised a lot of demos, and we'll talk about that, and we're about to jump into another demo right now. But let's talk about the attack that we're going to pull off. So this is a representative attack path of something that I did in a bug bounty not too long ago. It was a large payout, though the platform that I did it on isn't really known for large payouts, but it was about 50% more than the maximum than the what is normally allowed for this type of exploit. So it was a pretty cool, novel attack. It required a lot of different hoops to jump through, and we'll go through those hoops. The code that I use, the application that we're attacking, the exact exploits that I'm going to be showing are not the same, right? They don't participate in public disclosure. So, names and whatnot have been changed, but this is a very similar path. It's also represents a lot of attacks that I do on pen tests pretty often. So these are all, real world, though more illustrative than realistic kind of attacks. The first real demo, other than the cross-site scripting one that I told you we're going beyond, is an interesting one. So when we do like white box pen testing, a lot of times we get the code to analyze, and that code is extremely useful to us to try and hunt down vulnerabilities. And we're going to start off with some enumeration, right? So obviously, if you saw my last talk at Wild West Hack and Fest, it is a covert pen test. You're not going to be throwing Nmap at targets, but this is not a covert pen test. So we're going to start off with an Nmap scan of port 80. We know it's a web application, so we're going to just run port 80. And I'm going to do a -A, which is going to do service detection and run some default scripts and things like that. And we'll make this a little bit bigger because there's going to be a lot of output. And in this output, we see something very interesting. There is a .git folder accompanying this web application. Now, for those of you who are not familiar, Git is a source code repository software that handles version control. And it's great because it allows us to make changes and track changes to our web application, and multiple developers can participate in the application development at the same time. And it's super great. However, this should never be reflected in prod. Okay, you should never copy just like git checkout and then or git clone and then directly into var www. Okay, you should be copying the code over or removing the git files or and whatnot. Okay, so this is a mistake. This is a problem right now. So I created a directory specifically for Wild West Hack and Fest, and we'll cd into that. And when you see something like this, this does happen from time to time. I've seen this in the wild on a bug bounty. So when you see something like this, you can take advantage of this. You can actually download the entire tree with wget. And so we're going to wget recursive. We're not going to go into parent. So if we see any symlinks that takes us up in the tree, we're not going to go to that because we don't want it. And we're going to download, should have used a shorter DNS name for this, but we're going to download the Git directory, and I'll show you what we'll do with it in a moment. I know it's a directory. Come on. Why is this happening? I literally just did this last night. Ah! Come on, demo gods. What is happening here? wget-r np.
So it might be time to start slaughtering chickens.
Yeah, if anybody can help with the demo god sacrificing, that would be great. Okay, let's do this. I happen to have the code for this website right here. And so what's great about this is I actually have if you don't have Git, here's how we can, oh, somebody helped me here. That's exactly what happened. I dropped the C in corvidsec.net. Thank you very much, anonymous person. There we go. Okay, now we're recursively downloading. It helps if you type the web directory correctly. But as you can see, we're downloading a ton of files from in this .git directory. Now, this is all metadata that's used by Git to track changes and whatnot. But what's really cool about this, so if we cd into the correct corvidsec.net, and if we run an ls, all we have is the .git directory. We don't have any code yet, all right? But from here, we can actually get the code. So we can take a look at like what's going on by using git log, and we're going to do -- pretty. Just going to pretty up a little bit. And we want all of the Git commits in one line. With this repository, it's not a big deal because there's only 2 commits, but this really helps when there's, like thousands of commits or hundreds of. So we see 2 different commits. Now, we see a commit here that's removing the database creds from files and adding, credential file to git ignore and like doing some general cleanup. And this is actually also pretty common. So we actually want to revert a little earlier so we can get all the juicy stuff, right? We're going to do a git checkout. We're going to check out this commit right here that's identified by this hash. And then we're going to do a git reset hard, and that's going to bring us to the actual format that it was in for that commit. And so now we have all of the code that's associated with this website at this time, right? And we can start looking around and seeing all kinds of fancy stuff. But we're not quite there yet in our demonstration. What happens if we don't have Git? We don't find a .git directory. Well, if we have local file include and it's a PHP site, which this site happens to be, and most of the internet is because WordPress is PHP. If it's a PHP site, we can actually use a built-in PHP feature to also exfiltrate code. And I'll show you what that looks like in just a second. But we're going to make use of these PHP wrappers or these PHP filters that are used in the PHP wrapper. Okay, so this is what the exploit looks like, and we'll jump in just a second to demo that. If you notice up in, and it's a little hard to see, I can't actually zoom that, but if you notice up in the URL window, we have a page equals and site equals search.php. That is a little contrived, but very similar to what we see a lot in PHP sites, where you have like one main index page that's controlling the formatting, and you're just including code in there. What happens, and you see this a lot, is like we put in a bunch of //// and then Etsy password in here. And it's like, oh, look, Etsy password, that's so cool. But yeah, I mean, that's great for a demo, I guess, but what else can you do with it? Well, we're going to try and exfiltrate code. Now, when we do this, when we see like search. When we go to search, we actually see that we're already including the site here, right? And when we include the site, it's running the code. We don't actually get access to the code, which is unfortunate because we want access to the code. Well, this is where those PHP filters come in. Instead of putting in site search.php, we're going to do php://filter/convert.base64 encode/ and basically what we're doing is we're saying, hey, in the PHP wrapper, we have some filters that we can use, and one of them is to convert into base64. Now, shout out to Jeff McJunkin for first teaching me about this capability, and it's been gangbusters ever since. It's been super useful. So we're going to convert all of the content for the resource that we're about to ask for. In fact, resource is the next thing we type in. The resource that we ask for, we're going to convert it all into base64. The reason for this is that when a server that's configured to run PHP code sees PHP code, it runs it. And we don't want it to run it. We want it to just print it out. And if it sees base64, that's not PHP code, right? So it's actually going to print out the base64 for us. When we hit run, it kind of tanks for a little bit. Let's do this on a command line where it's a little easier to deal with. And if we curl this, whoop. Oh, there is supposed to be there we go. And when we look at this, we see this beautiful, huge block of base64 encoding. And we're going to make this text a little bit smaller so we can see it all in one screen. And this huge block of base64 encoding. Great. What do we do with this? Well, we're going to decode it, right? So we copy this, and we're about to do some really ugly, hacky Python. I apologize in advance for showing you this, but it's a really straightforward way to get it done. So when we copied it, there were a bunch of new lines embedded into the code. And we can see these here. So there's a new line here, there's a new line here, there's a new line here, and that's going to disrupt our base64 encoding. So if we base64, we need to import base64, import base64. Then we base64 dot b64 decode, and we're going to join a split at new line. And don't worry, I'll explain what this god-awful code is doing in a second. Okay, so what we're doing here is we're taking A, which has all the new lines in it, and we're splitting it into a list of strings, and we're breaking it at the new line to get rid of the new lines. And then we're joining with nothing. Now, you could do like a search and replace and a bunch of other functions, but this is a pretty quick way to do it. And when we do that, we get this. Now, this is the actual code for index.php. All right, so all we're doing really is just editing the file to get pure base64 and then decoding that base64. We're seeing things like cookies being set, and we see some different logic based on what post parameters are included and things like that. So this is actually the code of index. So again, if we don't have a Git directory, we can use LFI or other things to get that code if possible. Let's jump back into the deck for a couple minutes. We're about halfway through the attack path that we used for the bug bounty, and now we've got code. Now, what do we look for once we have the code? Because you could spend, a week or 2 weeks, or depending on how big the application is, a month, doing a code audit, and you just go line by line by line, like seeing where all the bugs are. But nobody's got time for that, right? I don't know any pen test firm that regularly gets 5-6 week engagements where they can just take their time and do things correctly. We need quick wins. And some of the quickest wins are looking for code execution paths or SQL injection paths, looking for filters and things like that. But the two biggest really are code execution. And there are two types of code execution. There's system calls and eval calls. So system calls are examples of a server-side code passing your input or passing parameters directly down to the operating system itself. Okay, so it passes the parameters down to the OS for OS execution. And this is an example of command injection. All right, this is great stuff. By the way, system calls and system execution are exactly what we're going to be doing in this demonstration. The bug bounty itself was actually an eval call, and that was where the server-side code, in that case it was Perl. I did my time as a Perl developer in my old Linux sysadmin days, and I feel like I have a right to complain about it. what we found was eval calls that were actually evaluating the server-side code in our input. And so we were able to inject, at that point, Perl code to change the way that the web application worked. And they were filtering a bunch of stuff, but they weren't filtering parentheses. So we were able to pull together this really ugly system call with parentheses. But this is an example of code execution, okay? It passes the parameters to the code interpreter, not to the operating system. Back to demos. So now that we've got some code, we kind of want to take a look at what the code looks like. Now, we don't want to search. We don't want to do line-by-line code evaluation. So we're just going to use grep, right? We're just going to make that a little bit bigger. We're going to use grep to search for different search terms in our application. Now, this is a presentation. I'm trying to keep this relatively real world, but this is a presentation, so I've got things a little scripted. I know ahead of time that shell exec is being used in one of the applications. What would you search for? Well, it was on the previous slide, right? We're going to be looking for system and pass through and exec and popen and eval and exec. It really depends on what the server-side language you're attacking is, right? So whatever the framework you're attacking is, you would do some Googling to see, what possible code execution, SQL injection phrases, et cetera, that you're going to be looking for. So in here, using this grep, we can see that connection checker is running a ping command for us. Now, we know that, looking at this PHP code, we know that it's taking our input from a post parameter and putting it directly into a shell exec statement running a ping against a target, right? So it's helping troubleshoot some connectivity issues maybe, but they're not sanitizing input. They're not doing anything but taking our input and putting it directly into the application. So let's check that out. We're going to go to the connectivity checker. We see that it allows us to ping other computers, and it's meant to assist troubleshooting, and we shouldn't use it for any nefarious activities. And, pen testers and hackers always listen to instructions, right? So super basic payload here. We're going to use a semicolon to escape out of the command that was being presented. We're going to run ID and hostname and date. Now, these are commands that I typically use in my reports because it lets us know who we're running as, what we're running on, and the date that it was ran, and it's just fairly good proof. Internally, we use another few commands to give more information about the target, but bug bounties, this is typically enough. This is a very straightforward payload. If it was doing any filtering at all, we'd have to start getting a little creative, but it's not built for that. It's built for, demonstrations. This is a very straightforward payload. Now, the great thing about what we did in pulling the code is if there were filters, we'd know about them. So even if we saw this connection checker earlier and was like, oh, well, this should be vulnerable, but we can't get anything executing on it. Once we get access to the code, we can see what the filters are and start devising ways to get around them. Okay. So instead of using ampersands and semicolons, we'll use pipes, or we'll use, subshells or something like that. Whatever they're not guarding against, we'll utilize. Which is why explicit deny filters are never good, because eventually somebody's going to figure it out. But if we submit this, we see that our code is running. So we get our UID of www data, and here's the host name, and here's the date in UTC, because that's the only time zone computers care about. Let's take this a step further. So what happens if there is no exec? Okay, what happens if there's no exec? Well, luckily, there's ways around that too. For this, we're going to need to talk about a little bit more nuance between the difference of a file include and a file open. Now, an include in most languages actually includes code. It's an import, it's an include, it's a whatever, and it's trying to pull in blocks of code into its running behavior to extend that running behavior. These are either libraries or just functions or whatever. This code is interpreted, and it will result in local file include and execution based on code. There are also file opens, okay, and these are for opening log files or writing to log files or manipulation of data. And exploits here are really for like data leakage and data corruption. You're not going to get execution out of this. What we did earlier, where we included the index.php this is what it should have happened. The file include should have happened. That code should have been interpreted, but we encoded it so it wasn't recognized as valid code. But we're going to use a file include. We're going to do a tactic called log pollution to pollute a log that is opened for writing and then include it using the LFI that we got earlier. And LFI really, especially in PHP, is just the gift that keeps on giving. It's so versatile. So for this, we're going to open burp, and I have burp open here. I'm going to configure my Firefox to use burp. And we're going to visit the admin page. When we visit the admin page, we see that it is logging access to our user agent. Say it says unauthorized attempt, and then it's logging the access attempt, and it says the user agent here. If we go into our code, which we have, and we less the admin endpoint, admin, we're going to see the cookie that it needs to be, but we'll ignore the fact that the cookie is listed here and look down, and we actually see that we're setting a user agent.log, and then we're going to open and write to it when we need to do logging of access attempts. So user agent.log is the file that we're going to be targeting. In our history here, we see that we went to the admin page, and we're going to utilize a burp feature called repeater. And this is the way I do most of my work. Some people do the intercept and interact with their requests like live. That's not really the way I work. I tend to get something into my HTTP history and then shunt it over to repeater. Then I can very quickly iterate through and fuzz through things manually. Since it's recording our user agent, we're going to remove that user agent, and we're going to put in our own code. Okay. Now, the user agent is used to tell the web server what information about our client, right? But it's also controlled by the client. And this is something that a lot of web developers fall into, is that you should never trust code that's coming from the client. So we're going to send this to the admin endpoint. And if we scroll down, we see unauthorized access attempt, logging access attempt by, and then here. We can assume that this has been now passed into that file. And if it's been passed into that file, then we should be able to include that file and actually have the PHP run. Okay, so there's PHP now in this inside this text file. And when a PHP server sees PHP files or PHP code, it tries to run it. This is kind of a server misconfiguration, though it's a default server misconfiguration, in that PHP servers should only be interpreting PHP in like .php files or .php5 or anything like that. But by default, PHP looks for PHP code almost anywhere, including you can like embed PHP code inside of an image file, and maybe not by default anymore, but for a long time by default, it would actually interpret that PHP code inside that image file. So instead of including the admin PHP information, we're going to use the user agent.log. We're going to include that. And when we hit enter, we should see the ID information, www data, pop up inside the access log. And here we see our failed login attempts both times. And then we also see the output from our command injection. And so this is another way, if we're able to get LFI and we're able to pollute the log in some way. Generally, this is by accessing a page with %20 PHP, and then you put your PHP code in the URL itself, and then you include like the access log or something like that. But if you're able to pollute a log that you can then include, you can get command and execution without having like a system or exec or eval or something like that in the code. So what are the takeaways? The takeaways here are that web apps are very complex and has many different layers, right? A lot of the mistakes that I see when I get interview, like pre-screen question back or talk to people in interviews, I'll give them a filter to bypass. And it'll be like, okay, well, here's a code execution vulnerability, but it's filtering semicolons. And the answer I'll get back is like semicolon URL encoded. And that shows a fundamental misunderstanding of, I'll put the slide back up here, shows a fundamental misunderstanding of how the web applications themselves work, okay? Because the URL gets decoded like when the server first receives the request, okay? And regardless of what server that is, it interprets the URL and then decodes URL encoding. The purpose of URL encoding is to not corrupt the URL itself. Because inside of various different things, you could have slashes and question marks and semicolons and things that mean something to a web server, right? If you put a slash in your get parameter, does that mean that it's a different directory that the web server should be dealing with? Or is that just part of the input code? What is that slash for? So we use URL encoding to say, hey, when you're interpreting the path, do not interpret this as a path component. Interpret the path first, then decode this, and you can pass it along. So URL encoding happens way over here. And then when it decodes the request application, then it passes it down to the business logic where the actual filters are. Okay, so you can use some nifty stuff to do malformed requests and bypass some server functionality behavior, but the majority of your filtering is going to happen inside the business logic, and that's after URL decoding has happened. So web servers have many layers, and it's important to understand how the application is working and the true capabilities of the web application and the language underlying that web application to be able to exploit. Knowing these PHP wrapper filters, knowing that the difference between opening a file and including a file or importing a file allows you to make LFI more than just something that reads Etsy password, right? It allows you to export code. It allows you to actually run code. It allows you to do many different things just from a local file include. I see a Shrek GIF in the in Discord, and I'm glad. Yes, there are layers. That is a Shrek reference. I tried to put like a Shrek picture in there. I know I don't have any memes in this. I apologize. But then also chaining exploits, right? It is very tempting to, once you pop an LFI, to just write up the bug bounty report and send it off. And yes, definitely when you find the LFI, write up the bug bounty report and get it ready. But don't stop there. Okay, don't stop there. You can move into other types of exploits. And now make sure that you're obeying the rules of engagement and whatnot, and you're staying within the scope of work. But you can chain exploits into each other and get some really nifty attacks and get bigger payouts and whatnot. The next slide is the thank you slide. I want to try and get through this bonus demo real fast. So there's another neat attack that I've talked about in the past, and this is actually something in Security 504, but a lot of people kind of like tilt their heads and it's like, yeah, right, does this really exist? But it's like second order cross-site scripting, and it's attacking admin applications. And this is a shout out to Moses Frost for pointing this out for the first time. When we go to the admin page, we see that it's logging the access attempt. Now, it's a reasonable assumption, or it is an assumption that you can make that this is going to be displayed to someone, right? A lot of times people have Splunk or Elk or something like that in the background, and that's how admins look at logs. These applications, Splunk and Grafana and Kibana and all these different applications, have all at some point had cross-site scripting vulnerabilities in them, which means at some point they were displaying unfiltered output to someone, that someone generally being an administrator. And so we can use a similar attack to what we did with log pollution, but instead of adding PHP to our user agent, we're actually going to put in JavaScript. And so when we send this, we scroll down and we see that there's an unauthorized attempt, and it says it's logging our information. Now I'm going to pretend to be an admin. Real quick, I'm going to open up the developer console, document. If you don't know that you can do this, by the way, this is super rad. You can set your cookies through the developer console. You can also set it through if you go into like network storage and then double click and whatnot, but you can do this. 8675309 is the cookie. We hit enter, and that set our cookie for this. So normally our cookie, if you remember from the code, if you were sharp-eyed, you saw that index was setting our cookie to user equals 2 all the time. But if our user equals 8675309, then we can actually access the admin page, and we actually get an alert pop up. Now, what's happening here is that we're abusing a file open to inject client-side code that is going to be stored somewhere and eventually seen by an administrator. Now, if we put a cross-site scripting payload that shovels this person's cookies off to a malicious server, we now have administrator cookies for an administrative panel. Okay? So this is an extremely effective attack, and like I said, Moses Frost first pointed this tactic out to me, and ever since I took his class, the web application pen testing class, I have always had cross-site scripting payloads in almost every header inside my burp. So it was just automatically replacing like my user agent and the accept language and things like that with cross-site scripting payloads that I can have up in another window, and just sometime 2 days, 3 days, 4 days later, I suddenly get a ping back to my command and control saying, hey, somebody displayed this cross-site scripting payload. So another super neat kind of little bonus lab for you. It's not something that I did in that particular bug bounty, but it is a very useful pen testing technique, and it's super, super rad when it pulled off. Now, disclaimer, I'm unaware of any cross-site scripting vulnerabilities in Splunk or Kibana right now. It doesn't mean they're not there, but I'm not trying to talk trash on those particular pieces of software. But every time I demo this, somebody's like, yeah, right, that doesn't really happen. It's like, no, go back and look at Splunk CVEs. There is definitely cross-site scripting vulnerabilities in its past. So this is something that does work in the real world. Anyways, that brings us 3 minutes to spare, so I'm going to sign off now. I have feedback if you're willing to scan this QR code.
I was going to say, if anybody has any questions, now's a really good time to ask.
Absolutely. I was actually going to move to the Track 1 voice channel, but we can do it here too. So, yeah, it'll be recorded that way, so I'm good with whatever.
Yeah. Everyone noticed that you had a typo.
Yeah, I did see that.
That was it. I think that's literally the only thing that people. I think that was literally the only thing people pointed out.
There were a couple questions in Discord. Let's see. So hypothetical situation: developer X says that his web app or web API is unexploited because it requires authentication and read only. What do you say to him/her? Authentication, as we saw, if we're able to dump code, authentication's really not that big of a deal. It also, that assumption makes the assumption that you don't have rogue employees or that, an employee doesn't sell some information. It's part of that egg model, right? Authentication is certainly a barrier, but it shouldn't be a substitution for secured code practicing. Read-only is great, actually. I love that it's read-only, but again, as we saw, there are client-side attacks that can attack admins that leverage into wider information. What terminal am I using? That's just Bash. I use a custom Bash prompt to show me some more information. There's tons of Bash prompt generators on the internet.
If you want one that's really, really cool, check out Fish. If you want a really nice prompt that has like autocomplete for commands and autocomplete within switches for commands, I really like Fish for people that are getting started.
Oh, yeah. I tend to stick with Bash because it's it's common everywhere.
It's Bash.
As a pen tester, spend more time in other people's computers than my own. So I try not to get too hung up on custom stuff. But yeah, Fish is great. Does XSS work on any input field, or is there a specific type that you need to look for? What you're looking for cross-site scripting is typically your information, your input being reflected back at you. If you type something into a web application and then it is shown to you, you're on the right path. Then you can look at the source and see if it's being encoded or something like that. But that's you're on the right path if you see it reflected back at you. And then as we saw in the second order cross-site scripting, if you see something that you have control of, so such as your user agent that's being logged, or you have a suspicion that it might be displayed to someone later, you can start fuzzing that and putting cross-site scripting in there as well.
There was another question I thought was a good one. It was said, how could I get Rook to explain everything to me? And that's literally just takes SANS 504. It's not everything, but it's a good start. It's 6 days.
It's a big chunk. Yeah, it's 6 days of me just like preaching and pontificating about why can't we all just get along and how can we just start a hacker hippie commune and things like that.
So here's one. I like this question. When hiring for an AppSec analyst, what do you think is the most important interview question?
Let's see. One thing that I've started asking pretty much every candidate, no matter what I'm interviewing for these days, is explain something to me that you know a lot about. And I try and make the caveat. I'm like, look, if it's tech, that's great. If it's not tech, that's fine too. Because what I'm really looking for is that curiosity that drives people to understand not just the what and the how, but the why. The thing I think I see a lot of people fall over on is they understand the what, and then they'll might even get the why, like the how. They're like, oh, well, it does this by doing this thing. And you're like, but why? Why does it do that? And if I see people really take that extra step to find out the why of something, then they have that curiosity and passion that I'm able to build on. And even if they're junior, I can teach them tech. Principal, I can teach them tech. All of that stuff, I can teach them. But the curiosity is really, really difficult to teach. And so it shows communication skills. If they can explain something to me, I'm not expecting them to be a polished speaker because nobody's born a polished speaker, but looking for their ability to explain concepts to people is also really important.
One of my favorite questions is, what is the difference between cross-site scripting and cross-site request forgery? And I want to make it clear that would only be a question I would ask somebody that is applying for an AppSec position. Like, they come in, they say that they've done this for a long time, and Jeff's saying woohoo. And we also use this as kind of an acid test for SANS instructors.
Yep.
Because there's things that you know in your head, and even if you do AppSec and you do it quite regularly, you may know the difference between cross-site scripting and cross-site request forgery, but can you actually boil it down in such a way
that
it's easily digestible for somebody else? And
so
I think
I was going to say I actually asked in AppSec, and specifically I'll ask AppSec people that are going to deal with web because it's a very web-focused question. But I asked an AppSec person that one time, and they started off with, well, you see, you steal the cookie, and I was like, whoa. I was like, hold on. Like, I understand, like, interviews are stressful, and it's very easy to confuse these two topics, so I'm just going to give you a second to kind of reset, and you can start again. And he's like, no, I'm good, and then just launches into it. And I was like, okay, man, we're like 5 minutes into this cross-site scripting discussion, and I asked you what cross-site request forgery is. And I start kind of like demoing, like drawing up the stereotypical, like, here's a bank website. And he's like, no, that's not what it is. And I was like, bro, this is the one time I make a lot of jokes about me saying, do you know who I am? But this is like the first time I was like, do you know what I do? Like, do you understand like the stuff that I do here? And later on, he told me to Google it. He's like, well, maybe you just want to Google it. And so we sat down. I was like, okay, well, you've got about 10 minutes left, and I want to give you time to ask questions. And so he's like, so what, what's your role here? I was like, well, I run the offensive security team. He's like, yeah, but like, what is that? And I was like, well, we do web app pen testing like daily. Like, we do this. Oh, and on the side, I'm a SANS instructor where I teach this to people. So, and he was like, oh. I was like, yeah, man. Yeah. He didn't get the job.
Well, somebody was saying, oh my God, what's the resource to answer that? It's actually pretty basic. Whenever you're talking about cross-site request forgery and cross-site scripting, it's where the code ultimately executes. In cross-site scripting, it's going to execute in the victim's browser, and in cross-site request forgery, it's going to pass it to a server where it's going to be executed. That's the quickest, easiest answer for it. And there's some really cool things where you can use cross-site scripting to execute cross-site request forgery as well. So
those are great bug bounty write-ups, by the way. That's huge, cross-site scripting and a cross-site request forgery. Somebody asked if you got the job. Listen, I'm all about people challenging me in interviews. Just be correct. I'm wrong just as often as everybody else is, and sometimes I get caught up and whatnot. But if you like double and triple and quadruple down when I'm giving you outs, and you're not correct, you're not going to get the job. Like,
you hate to be that way, but I think the willingness to kind of back down and say I don't know is more important. I mean, because at this point, seriously, Rook, you can tell when somebody's just pulling things out of their ass.
Yeah, and somebody asked about my favorite, like the best questions to ask. My interviews are always push them to the edge of what they know, and then push them a little bit farther. And I'm looking for critical thinking. And them saying they don't know is fine. I'm like, cool, you don't know. Let's think it through. Like, let's talk about it. And sometimes I don't know. Like, sometimes I'm just like, hey, let's talk about it, But I've been around long enough that even if I don't know, which there's a lot of things I don't know, I can tell if you're just making stuff up. It's very apparent to me. So
my favorite story of that is years ago, whenever they were kicking out the new web app pen testing class at SAND, Johannes, myself, and I can't remember who else, we were murderboarding Jonathan Ham. And that was tough, right? Because that's a really tough group of people. And the SANS Institute's way of vetting instructors used to be that exactly what you just said, Derek. You're going to push people up to the point where you feel like they're about to break, and then you're going to shove them off the edge because you really need to see how people fail. And there's good failures and there's bad failures. Just talking out your butt is a bad failure. But going through and saying, you know what, I don't know. Hey, everybody, let's open up Google and let's check it out and let's kind of pull it together is there's better failures, right? And we were murderboarding Jonathan Ham, and Jonathan was doing a good job. He was answering all the questions, technically accurate. And Johannes, when it was all done, had this great quote. He goes, well, Jonathan, I think you did okay. You got all the answers technically correct, but it sounds like you were making it up the whole time because he was giving a hard time about it. But that's just the way we used to do things at SANS back when we weren't the kinder, gentler, precious snowflake SANS.
So my murder board was Ed Scotus, Mike Murr, Kevin Fiskus, Adrian DeBeaupre, and Lisa, in fact, jumped in on it. Yeah, Lisa actually started heckling as well, which I was pretty proud of. But yeah, it was rough.
Yeah, and that's the way it should be, right? I mean, Jeff McJunkin, the link guy, he's the only person in the history of me doing murder boards that came back like 5 times. Like he just kept coming back again and again, and he's like, I got to get this, I got to get this, I got to get this. And you know, he's like a monster.
Shout out to Jeff. Huge help at the conference, this conference, but also Jeff helped me prep for my murder board. It's just a generally all around guy and just doesn't quit being a good guy.
Yeah, it's just in his DNA.